In order to have a proper mental model of Node.js, we first have to have an accurate understanding of its core, the thing at the heart of Node.js, the V8 JavaScript engine. And that's what our first major section of this course will discuss. To begin with, our first lecture in this section is a conceptual aside. We need to understand processors, machine code, and C++. And before you say, hey, I'm here to learn about Node.js and writing JavaScript, well, just hang with me. Trust me. This will be an important part of having a proper mental model of Node.js, which will make you a far better Node.js developer than maybe even those around you. All right, so processors, machine code, and C++. So first of all, let's talk about the thing that's sitting inside your computer right now as you're listening to this course. The thing that's making this video work. The thing that's making you hear the sound, ultimately. And that's your microprocessor. You know, when you buy a computer, you look at the processor speed and type. But what is a microprocessor? Well, for our purposes, we can simply think of it as a very small machine. And that's what it is. A processor's machine with very small parts that work in tandem with electrical inputs and ultimately do a job. We give the microprocessor instructions. The microprocessor speaks a language. Now, not all microprocessors are the same. In fact, they don't all speak the exact same language. When we give instructions to the processor on your computer for it to run a program, it's going to get those instructions in the particular language that it understands. It has to, or else it won't be able to run. And there's a variety of sets of instructions or languages that microprocessors may be designed to speak. Now, a microprocessor in general will speak one of these languages. Some processors speak IA32. Some speak x86 for 64-bit machines or 32-bit machines. Some speak ARM. Some speak MIPS. The processor is a physical thing. It's something that you can hold in your hand. You are right now if you're holding a laptop or if you're holding your cell phone or your tablet. It is a machine. And it's a machine that accepts instructions and carries them out. And the instructions themselves then, again, there's a variety of languages, and a microprocessor will speak one of them. And there's actually quite a number, but these are some of the most popular. Now, if I say this set of instructions, what I'm really saying is code, computer code, that I'm giving directly to the machine. So we call that machine code. Okay, hang on a minute. Big word alert. Machine code, or sometimes called machine language. These are programming languages spoken by computer processors. And every program you run on your computer has been converted, or sometimes called compiled, into machine code, into machine language, into the machine language that your computer processor speaks. All code eventually becomes machine code. It has to, because the machine is what carries out the requirements. Machine is what carries out the job. So ultimately, whenever we're writing a programming language, there's some other process that's converting what we're writing into something the machine, the processor, can understand. And sometimes it converts it into many different languages so that your program can run on many different computers, many different processors. So why don't we write machine code directly? Well, some people do, but there's a reason why we don't write much machine code, the majority of us developers, anymore. Let's take a quick look at what some machine code might look like. Ready? And here it is. What do you think? Easy to understand? Now, again, different instruction sets, different machine languages will look different for different machine languages that different processors support. But this is essentially the kind of thing that you would be seeing. These are instructions that have to do with memory, specifically what to do with what pieces of memory on your computer. This is very, very low level. And so instead of directly writing machine code or machine language, we write in languages that are converted or compiled into machine code. And as time has gone on, we've gotten further and further abstracted away from lower level code and into writing more high level languages. So machine language, which is directly speaking to the microprocessor, you're not abstracted away at all from what's really happening. There have been levels of abstraction added to us that get us to this modern era of computer programming. So there's things like assembly language that came later that is still pretty close to machine language, but a bit easier to understand and read. And then there was a huge era of C and C++, when that really took off. C and C++ is still used heavily today, but its syntax, if you see it, looks a bit more like JavaScript or Java, because Java and JavaScript were inspired by what's called C syntax. That is the way C and C++ programs look when they're written, things like curly braces and functions. But C and C++ still lets you have a degree of control that's lower level, and so a bit closer to the microprocessor itself. And that's why it's very popular to use, because you have a great degree of control, but it's easier to code in than assembly or machine language. And then you have programming languages, very high-level programming languages like JavaScript, which are very far removed from the computer's processor. You don't deal directly with where memory is and what it's doing. You have an engine between you and the microprocessor that's taking care of all those things for you. So when we're talking about writing JavaScript, we're really talking about writing a programming language that some other programs are going to convert into something like machine language. And that's not to say that you have to go down this tree, that JavaScript becomes C or becomes assembly or anything like that. You can jump around. Perhaps JavaScript gets converted directly to machine language. But nonetheless, something is going to do that work. So we sit very high in these levels of abstraction as modern developers in web development. We sit very far away from the microprocessor. And as a result, we can have improper mental models of how something like Node.js is working. So we need to and should have a proper understanding of what's really happening. So here's the first thing to really understand about Node. And this is the first thing that people are often confused about or have a misconception. Node is written in C++. Now you might be thinking, whoa, wait a minute. Everything I see about Node and when I'm trying to learn Node.js is about JavaScript. When I'm writing Node, I'm writing JavaScript. Well, that's true. You're writing in JavaScript. We write in JavaScript when we write Node programs, but Node itself is written in C++. It's a C++ program. And the reason why Node is a C++ program, is written in that programming language, is because V8, the JavaScript engine, is written in C++. V8, the thing that converts JavaScript to machine code, is written in C++. And so Node, which adds on to it, is also written in C++. Now, this is important because we're going to keep diving into V8 and Node a bit more, and that means we're actually going to see a tiny bit of C++ code. But don't worry, we're not here to learn C++. You don't need to learn C++. What we're trying to establish is a foundation of knowledge that will help you then when we move on to writing Node programs in JavaScript. All right, let's move on.